Hello everyone, welcome to my YouTube channel. So in this video, we're going to talk about electromagnetic field tensor. So as you can see, the form of the electromagnetic field tensor in the matrix form is already available in front of you in the screen. So in this video, we're going to see how this F nu, which is our electromagnetic field tensors, like what is the derivation behind it? How we'll actually derive it from the equation, from our Lie, from the Lie section, from our action from our S. So it's like, yeah, as you all have seen in the previous video, that the action, the action that we define action as integration of minus mc ds, yes, mc ds minus e by c ai by dxi, right? And to find the variation, what we take, yeah, and to find the equation of motion, we take the variation and we set that variation to zero, right? So this is how we find the equation of motion. And for any action, right, we take its variation and we set that variation to zero. So now we have you have now action. Now what we'll do is we'll take a variation of this action. Okay. So what will happen? It will look something like this: minus mc ds minus e by c ai dxi. Now, since integration and variation are interchangeable, so what happens is this variation symbol get inside the integral. Okay, and what happens is minus, and it turns out, so our equation turns into this form of dxi by variation of some d del xi by ds. Here ds is dxi by dxi. How, yeah, just remember one thing, that this variation thing is ex exactly like this is different. It has different meaning, but its properties are almost in every form are almost same as derivative. So it is nothing but we have applied the chain rule and we came into this form. Okay. Now we similarly will apply the variation over here. We'll again apply we'll apply this, sorry, this rule, and what we'll get is we'll first take the variation of the ai and we'll keep the dxi as constant, and again in the next one we'll take the variation of dxi and keep ai as constant. This is variation of d del xi. Again we did this because derivative and these things are interchangeable. Suppose we have something like this of some xi term, variation of xi term is equal to derivative of variation of some xi term. Remember that. Okay. Now, okay, that's good. Well and good. Now what we'll do is we'll do integration of by parts of this part, okay, and this one, right? We'll do the integration by parts of this one. Now, what for our convenience, what we'll do is take this term ds as some ui. Okay. Now, variation of ds when you do the integration is, so this thing will look like ui into d to variation of del xi. This thing is some e by c into ai. I'm taking this term over here as d del xi. Let's use this. And e by derivation of del ai dx. Now what we'll do is do the integration by parts. So when you do the integration by parts, or further this is same as or we're taking a variation. So when you do this thing, what we'll get is minus mc. We'll do the integration. Yeah, just a second. Uh, for convenience, what we'll do is we'll consider this as, yeah, we'll integrate this function and we'll do the derivative of this function. So what we'll get is, when we take the integral of this, we'll get some variation of xi, right? And on the other hand, we'll take the derivative of ui and we'll take the integral of this term, which will gives us variation of del xi. Okay. Similarly, we'll do something similar over here. So we'll do the derivative of this term and integrate this term. What we'll get is e by c ai of n variation of xi plus e by c dai integral of dai variation of xi. And one more thing we'll get, and we'll have this other extra term, which is e by c integral of variation of ai variation of dxi. Okay. Now what we'll do is we'll take this integral term and all this integral term in one box, in one side, and on all the non-integral terms on the others. Okay. So what we get is integral of minus mc du. Okay, just one thing. We'll just put everything in a box. Dxi plus e by c into dai variation of xi minus e by c variation of ai into variation into dxi, right? And all the non-integral part which does, all the parts which doesn't have any integration, we'll keep it in another box, which is mc ui plus e by c ai variation of xi. Okay. So this is our variation of s. Now what we'll do is we'll set variation of s is equal to 0. This means this whole part, are individual whole, this whole thing is equal to 0. Now since we're not changing our, since our, since the, since the integral is varied with fixed coordinate values, so this term, this del x term will go to 0. So this overall term will go to 0. So what we get is, uh, so since we're working with fixed coordinate value, so only this part is going to 0. So what we get is integral of mc dui by variation of l dxi plus e by c dai into plus e by c del ai dxi. This thing is equal to 0. Well and good. Uh, Now we'll do some juggling with the terms, and what we'll do is we'll multiply, we'll bring an extra term, which we will what we'll do, we'll divide this dui by ds. Okay. And we'll take all of this del xi this del xi outside. Okay. So what we get is, and what we'll get is something like this. Okay. Now if you see carefully, this is nothing but our electromagnetic field tensor. This thing over here. This is nothing but our F mu nu. Something, right? This is our electromagnetic field tensor. Just the correct thing will be to write FIK. This is our electromagnetic field tensor. Now, on what this equation changes is equal to this form. This is our equation of motion. Okay, and this thing can also be written as dui by ds is equal to E by C into F by K by UK. Okay. I hope you got understood how it's done, how we can uh, find the electromagnetic field tensor for our action. I hope you find this video knowledgeable. And if you do, please just don't forget to like, share, and subscribe. And thanks for watching.